Good day to all. This is Remya Rose, Assistant Professor from Department of Artificial Intelligence and Machine Learning from RMD Engineering College. In this video, we will be discussing on the topic Deque under the subject Advanced Java Programming with the subject code 22CS307. To say of Deque, first we need to know the full form of Deque. The Deque stands for double-ended queue. You can also pronounce it as Deque. So double-ended queue, by the name you can understand, they holds a data structure which we know already, queue structure. Normally for maintaining, storing and retrieving of information or data, we use the basic data structures like stack or queue for any programming. If suppose we are using the stack data structure, the stack follows the last and first out, whereas the queue follows the first and first out. But there are certain scenario where with respect to priority purpose, we need to do certain modification in the adding, removing and iterating of information with respect to the stack and queue. So normally, if suppose we are using a queue data structure, we keep adding element through the end, and we keep removing the element from the other end. Say when information is added, the new information would be added behind the first one and then behind the second one and so on. So the element that was added as the first element will be popped out or removed first. So we call that as first and first out. But in certain scenario, with respect to some versatility with priority, some elements that are added to the last position may need to be removed first. In that scenario, we use a new data structure. We call it as Deque. The Deque works both like a stack as well as like a queue. Means with respect to the scenario or with respect to the objective of our program or the test case, we can make the data structure act as queue or as stack, which means that in both the way you could keep adding information and in both the way you could remove the information. Say you can insert element both from the front end and the back end. Similarly, you can remove the information or data from the front end and the back end. So in a shorter gist, if you could see, a Deque interface has got some new methods apart from the stack as well as queue data structure. It has got some new methods for inserting and removing entries from both the ends, front and rear. So this is mainly used for efficient insertion and removal operation. So when we want to use the Deque interface, you need to declare the Deque interface properly. So this is the syntax of declaring a Deque interface, which says public interface means public Deque and extends a queue, where since the access specifier is public, you can access this interface from any where from the class, and this is extending queue, where you can also use the methods that belongs to queue. And as we have discussed in the definition of Deque, this data structure has got this interface has got certain additional methods which we normally don't have with queue as well as stack in the other concepts, where we would see few of the unique methods that is available with Deque. One is add first, add last. Why I wanted to mention these methods is that Deque, I told you, it could act both as a stack as well as the queue. Means you can add and remove information from both the ends. So we can use add first to insert a specified element in the front of the Deque. You can use add last to insert a particular element in the rear end of the Deque. Similarly, you could do a remove first to remove your first element, or you could use a remove last to remove your last element. Also, get first and get last will not remove the element from a Deque, but it will retrieve and give you what was the first element and what was the last element from a from that particular DQ. And Boolean offer first says that it will insert the specified element, say element E, at the front of the DQ and return if that is true and if that is successful. And Boolean offer last inserts the specified element at the end of the DQ and returns true if that insertion is successful. We will see a simple programming with DQ interface. So similarly, if we are using DQ concept, we will be importing the package import java.util.dq. Since we are using RADQ, we have imported that package too. And now this is the declaration of DQ interface, which we already saw in the definition part. DQ, then the type of the element, then the interface name, and we have implemented it as a RADQ. And with the basic methods we have discussed earlier, we are inserting elements to that particular DQ. And we can also remove element from the DQ. So here I have inserted 3 tasks, task 1, task 2, task 3, and I have removed the first element. Thank you.